everyone. This is Dr. R Shakuntaladevi, Department of Physics, Trinity College for Women, Namakkal. Through this presentation, I can give some basics of coherence waves. First, we can understand the path difference and phase difference of the waves. We all know the light waves from the source travel in the form of waves. Then, the path difference between the two waves is the difference in distance traveled between them. So, it is symbolized by del. Similarly, the phase difference is the angle difference between the two waves. So, the relation between them is phase difference equal to 2 pi by lambda times the path difference. The path difference and the phase difference are I clearly explained the given figure. Next one is coherence waves. Coherence waves means which have no phase difference or constant phase difference between them. We know the waves travel in sine waveform. At a particular distance, the waves are unpredictable. So, the length of the wave to have a pure sine waveform is called coherence length, and the average time during which the phase of the wave can be sine waveform, then it is called coherence time. Based on the consideration, the coherence have two types, that is temporal coherence and spatial coherence. From the figure, S is the source and P1 and P2 are 2 points. That these 2 points are considered longitudinally in figure 1 and laterally in figure 2. So, the temporal coherence means the longitudinal relation between two waves, and spatial coherence means the lateral relation between two waves. So, in temporal coherence, it is related to the bandwidth of the source, but in spatial coherence, it is related to the finite size of the source. Now we can see interference. Interference is nothing but the superposition of two coherent waves in a medium. From the figure, we can produce two set of waves, and these two waves are superimposed at some points. Based on the intensity, the superimposed wave can be two types. That is, the interference has two types. First one is constructive interference. It means the intensity is maximum. Next one is at which point the intensity is minimum, then it is called destructive interference. Then in destructive interference, the resultant amplitude is the difference of amplitude between two waves. In case of constructive interference, the resultant amplitude is the sum of two amplitudes of two waves. The instrument which is based on the principle of interference are called interferometers. Next, we are see about some interference based instruments. First, we see about the air wedge apparatus. Air wedge is nothing but a wedge-shaped air film formed between two glass plates. From the figure, L1 and L2 are two glass plates. It will be tied at one end, and a specimen, that is a thin wire, is inserted at the other end. The gap between that is filled by air. This setup is called air wedge. If we focus a monochromatic light at an angle of 45 degree to these glass plates, then through the telescope we get a number of alternate dark and bright fringes. These fringes are called interference fringes. The fringe with beta equal to lambda L divided 2D, where lambda is the wavelength of the incident light, L is the length of the glass plate where the tied end to the specimen, and D is the diameter of the wire. Next, what is the application? The air wedge apparatus is used to measure the diameter of a wire and testing the flatness of a given glass plate. Second, we can see about Michelson interferometer. In Michelson interferometer, a beam of light from a source divided into two equal parts of equal intensities by partial reflection and refraction. These waves travel in two perpendicular directions and come back together to produce the interference fringes. In Michelson interferometers, we have two mirrors. The mirror 1 and mirror 2 are decided the output of the interferometer. If the mirror 1 is fixed and mirror 2 is movable with respect to mirror 1. If the angle between these two mirrors are exact perpendicular, that is 90°, we can get circular fringes. Otherwise, we can get straight fringes. If we can use white light, we can get white fringes. The Michelson interferometer is used in wide applications. It can be used to find the difference in wavelength of sodium D1 and D2 lines using the formula d lambda equal to lambda 1 lambda 2 divide 2 into x, and using to find the thickness of thin transparent plate by using the formula T equal to m lambda by 2 into mu minus 1, and to find the refractive index of a given gas, the wavelength of given monochromatic light. Lastly, we can see about Febry-Perot interferometer. It consists of two optically plane glass plates with the inner surfaces are silvered up to 90%. That is, only 90% of the ray are reflected between these two glass plates and 10% light is refracted away from the glass plates. So, an incident ray suffers a large number of reflections between these two plates. So, it is called multiple beam interference. Using this method, we can find the wavelength of the given light by using the formula lambda equal to 2 into x1 minus x2 divide n. Now, the conclusion. Through this class, we can see about the path difference, phase difference and relation between them, and what are coherence waves and what are its types, what is interference and the types of interference, and the instruments based on interference, that is types of interferometers, that is Air Wedge, Michelson interferometer and Febry-Perot interferometer, and what are the applications of interferometers. So, dear students, interference is the basic phenomenon of light, so we can understand the concept clearly. And finally, thank you for watching.